Hi, I'm Cressel Anderson, this is Makercise. In this episode, I'll be making the bull wheel assembly for the Shaper project.
I get a lot of really helpful feedback from the comments. This is one example of that type of feedback. I've started using a hot rod to melt the inside of the sprue. That way the aluminum has less material to burn through, and it gets right into the pattern pretty quickly.
Because this pattern has a recess so that I don't have to drill as much, I can just kind of get started boring it. I'm going to mix up a little bit of sand into the plaster of Paris and try to fill that. I'm also going to have a little bit of sand in the coating just to see how that performs relative to what I've been using, which is just straight plaster of Paris. The reason that I'm not using drywall is because I want to cast this today. It's supposed to rain tomorrow and the plaster of Paris will set up much quicker. I've really been enjoying lost foam casting, and one of the things I thought I would try is making a vibratory table to help the sand settle in around the patterns. And I basically just took a scrap motor that I've had for 10 or 15 years, made a little DC power supply converter thing for it, tested it out on the bench. Then I fabricated a counterweight to mount on the shaft of the motor from a piece of cold drawn steel. I mounted the motor assembly to a sheet of melamine. Then I put the melamine sheet onto a tire. I put the flasks on top of the melamine board. And then I fill it a little bit with sand, put the pattern in, and fill it more with sand. As the table vibrates, the sand fills in nicely around the pattern. And so far I like this method. There's other techniques like air injection that I might explore at some point in the future.
I spent a while boring out the bearing support to the rough diameter, but then I decided, for that last little bit, I wanted to try to be a little bit more precise. So I decided I'd make a graduated dial to go on the cross-slide feed screw. And I did that by basically just drilling a hole in some aluminum flashing. I made a radial pattern using Adobe Illustrator and printed it out. I glued that printout to the aluminum flashing and then trimmed it down to size. When I put this on the cross-slide feed screw, I just left it loose, and that way it can kind of rotate freely. I can use those marks by eye just to kind of get in pretty close, and I'm really happy with how that mechanism turned out and how close I was able to get the bore to the finished diameter that I was looking for. A press fit makes me feel like an actual machinist. One thing, though, that I didn't anticipate was there is flex in the faceplate where it connects to the spindle, and that has the undesired consequence of making the backside of the bored hole larger in diameter than the side closest to the tailstock.
That's nice.
There's probably ways to compensate for this. However, for my purposes, I just figured I would try out some red Loctite, keep it from slipping around in there. We'll proceed with that as is.
I need to get this bull wheel sprocket centered up on the faceplate. What I decided to do was I had this, it's probably like a 5/8 inch rod that came out of a treadmill that I salvaged. It has a center on the one end. So I took off the tailstock and I'm going to slide this in there and use it to pretty much line up on the center. And then I'll indicate and make any kind of fine adjustments. It's like about 20 thousandths, 10 thousandths each direction. A little bit over that. I cut these trapezoidal shaped pieces of cold rolled steel. They bolt onto the bull wheel sprocket. there is a little insert that slides in between these two. Wherein a shoulder bolt affixes and clamps at various placements along this channel, and that allows me to vary the throw from long to even short depending on where this crank pin is located on this bull wheel. Clamp all these pieces together, drill it, then they're perfectly aligned, and they'll be aligned so that this hopefully will be able to slide without much filing.
I used a Dremel to make some marks on the different parts just to keep track of how they assembled. I used my homemade bench block to transfer the holes from the bearing support into the column side. After those holes were marked, I enlarged the holes on the bearing support. These enlarged holes will serve as a guide for the tap that I'll be using to cut threads in the column side. After I had the first two fasteners in place, I went ahead and drilled out the bottom two holes and installed the remainder of the fasteners by repeating the process. I cut the crankshaft to length and then test fit the bull wheel. I didn't have the proper size shaft collar for the crankshaft, so I had to bore out one that I had in stock. The bull wheel is driven using a chain, and there will be a smaller pinion gear mounted at the back of the column. I hope this project builds your confidence to exercise your inner maker. In the next step, I'll be fabricating the Scottish yoke that connects the bull wheel to the ram. Thanks for watching.